So in this problem, we are provided with a rational fraction and our goal will be to resolve into its partial fraction. Well, let us begin. So we'll start with a given rational fraction and we will suppose that this rational fraction x cubed minus 2 divided by, so in the denominator we have the product of two factors and both the two factors are quadratic in nature. The first factor being x squared plus x plus 2 multiplied to x squared plus x plus 1. Now, since we have two factors in the denominator, so we're going to get two partial fractions, meaning we can resolve this particular rational fraction into two partial fractions. Right. The first partial fraction, let's start with the denominator. We're going to consider the factor x squared plus x plus 2. Now, in the numerator, since we have a quadratic factor in the denominator, the numerator is going to be represented by ax plus b. Then the second partial fraction, the denominator portion, is going to be x squared plus x plus 1 and the numerator is going to be denoted by cx plus d. So our goal will be to determine the value of a, b, c and d. So let's begin. We're going to label this as equation number 1. So what we'll do, we'll take equation number 1 and multiply throughout with the denominator such that we get x cubed minus 2 equals to, so we have x squared plus x plus 1. So this will be multiplied to ax plus b. Added to x squared plus x plus 2. So this will be multiplied to cx plus d. Fine. So we have x cubed minus 2. So that's equals to. Now what we'll do, we'll combine the like terms. So here we have the highest part of x. So that's going to be x cubed. So we have x cubed times a plus c. Then we have the next term, which is going to be x squared. So x squared is going to have the coefficient a plus b plus c plus d. Plus we have the next term, which is going to contain x, is going to have coefficient a plus b plus 2c plus d. And then we have the constant term, which will be simply b plus 2 times d. Now clearly we have four terms in the right hand side. So the first term consists of x cubed, second term consists of x squared, third terms have x, and the fourth term is the constant term. And if we consider the left hand side here, we only have two terms. One contains the term x cubed and the other term is the constant term. So what we can do, we can rewrite two more terms here. So we will consider the x squared term having coefficient of 0 and the term with x having coefficient of 0, so that we also have four terms on the left hand side. Now what we'll do, we'll equate both sides. So if we equate both sides, equating both sides means we are going to equate the coefficients of x cubed x squared x with the coefficient of x cubed x squared x on the left hand side. So that means we will get a plus c, so that will be equals to, so we have x cubed here, so it has a coefficient of 1. So a plus c will be equals to 1. Then you go to the next coefficient of x squared, so a plus b plus c plus d. So that's going to be equals to coefficient of x squared on the left hand side, so that's 0. Then we have a plus b plus 2c plus d. So that's the coefficient of x on the right hand side, and this will be equals to coefficient of x on the left hand side, which is 0. And then we have b plus 2d, the constant term, that's equals to negative 2. Right. So we have four unknowns and four equations. We can solve them to determine the value of a, b, c and d, which I'm leaving as an exercise for you to try out. I'll state the values. A value is going to be equals to 1. Then b value is going to be 0. C value, that's going to be 0 as well. And d value, that's going to be equals to negative 1. So when we substitute all this value back in number 1, and then we're going to get the final result. So let's note that down. So we have x cubed minus 2 whole divided by x squared plus x plus 2 multiplied to x squared plus x plus 1 equals to, so we have ax plus b, a being 0 over 1 and b being 0. So we have x divided by x squared plus x plus 2. And then we have cx plus d, c is 0 but d is negative 1, so we have negative 1 divided by x squared plus x plus 1. So this is how we have successfully resolved the given rational fraction into its constituent partial fraction. The first one being x over x squared plus x plus 2. And the second one is negative 1 over x squared plus x plus 1. And if you want to cross-check, you can combine the two partial fraction and this should get back the original rational fraction.